So our frequency depends on the length, the tension, and the mass per unit length, right? So if it depends on that, it means it is directly proportional to all these three quantities, right? So from here, we are supposed to raise them to variables. Let's say this is x, this is y, this is z. So then f, we remove the proportionality side and bring a constant. Let's say it's k, l to the power x, t to the power y, and m to the power z. So from here, we should put them into square brackets to find their dimensions. So k is a constant which is dimensionless. L to the power x and t to the power y and m to the power z. So what is the dimension of frequency? So frequency is the inverse of period. So it's going to be t to the power -1 because period is time. So L is our length, which is capital L, and if we also look at our tension T, it's a force. So tension is the force in a string, and it's mLT -2. So m is the mass per unit length, right? It's called the linear density. Linear density is defined as mass per unit length of a material. So it's mL -1. Yes. So we substitute t to the power -1 is equal to k, then L to the power x times the tension, which is mLT -2 to the power y times mL -1 to the power z. Yes, but our k is 1 because it's a constant. So t -1 is equal to, we're going to have L to the power x times mLT -2 to the power y times mL -1 to the power z. So we could expand this times m to the power y, L to the power y, and t to the power -2y times m to the power z and L to the power -z. So we can collect our like terms. L to the power x times L to the power y times m to the power -z. That's x plus y minus z. So for the m's, it's going to be y and z, y plus z, and then t to the power -2y. Yes. So by comparing, we have, so I want to bring m and l on this side. It's going to be m to the power 0, L to the power 0, t to the power -1. So this is 1 times t to the power -1 is the same as t to the power -1. So we could arrange this as m to the power y plus z, and then L to the power x plus y minus z, and t to the power -2y. So I would start with t. T to the power -1 is t to the power -2y. This and this cancel, so -2y is -1. We divide both sides by -2, so it means y is 1/2. I want to compare the m's, so m to the power 0 is m to the power y plus z. That means y plus z is equal to 0, and then z then will be equal to -y. So negative of 1/2, it means z is -1/2. So we got z, and we have to compare our L, and then so L to the power 0 becomes L to the power x plus y minus z. This and this cancels, so that means x plus y minus z will be equal to 0. So we got y and z, we need x, so x will be equal to, when z moves it becomes positive, this one becomes negative y, so x will be equal to, z is negative half minus y, which is also half. Yes, so LCM is going to be 2, so I have minus 1 minus 1 minus 2 divided by 2, so that means x is equal to minus 1. So we got the values of x, y, and that of z. So we bring down the equation. F is equal to k L to the power x, t to the power y, and m to the power z. F then will be equal to k L to the power x is negative 1 times t to the power y, which is 1 over 2, and the mass per unit length m, which is negative half. So F will be equal to k. So L to the power negative 1 means inverse of L times square root of t times, so m to the power negative 1 would be 1 over the square root of m. So then F will be equal to k root of t over L root of m. So when we try to join these two, that is these square roots, we're going to have F is equal to k over L square root of t over m. So this becomes our equation.